Hello guys and welcome back to a new video. My name is Noel and I'm here to teach you about Hess's Law and enthalpy cycles. Now this is an OCR A Chemistry 3.2.6, but you should be able to find this in other exam boards too, and I suggest if you are from another exam board, stay and watch this video as it could help you. Now let's begin. So this video should help your understanding of Hess's law for construct with regards to combustion, formation and other unfamiliar substances or equations, for example. Now this should also show you the techniques and the procedures needed, and later on in the video we'll go through some practice questions and then we'll let you try one on your own. Now some of you may be wondering, what is Hess's law? Now simply, we have to go all the way back to a time when Gemain Henri Hess lived. Now he is a chemist and a medical doctor, and he made this idea a law now, that enthalpy change in a chemical reaction is independent of the root. Now many of you are wondering, what does this mean? So enthalpy change is the energy from a reaction, right? And this guy is saying that no matter which route you go, that energy should be independent. And now you guys might be wondering, why is this useful? We don't need to know this. The problem is that many people are wondering, say this plus this equals to that. But then it might not be possible, it actually might be impossible to create that chemical. But however, you can go for an alternative route that will get you the same amount of energy as going through that route. And this helps you find the enthalpy for that ABC route, even though it's not possible, because of this man's little law. So let us show you a common example right now. So you have A, B and C with an enthalpy of 500 kilojoules. Now imagine it's not possible at all. So now we know that a different route called AB plus D is possible, and then magically that D can become C. And with this information we're able to draw something called an enthalpy cycle, as seen here. Now you guys might be wondering, what is this actually called? And what is an enthalpy cycle? So as you can see, this is a pictorial representation showing alternative routes. So here, let's put that in another color. Here we have our made up route, right? AB plus equals C. Now we know that's not possible. However, we can go through a route called A plus B equals D, and then this makes C. Now with the information that we had, true or not, we know that this is 500 kilojoules. Alright? Now, two extra information you should know is that the arrows show direction. So we have this arrow here, right, going that way. So that means this should be, if it was going this way, plus 500. But if it was going this way, however, it will be minus 500. Now let's say we want to find out this route. So let's say this route here was minus 1000, right? And this route here gave us plus 1500. Now, as you see here, we have this rule. Delta H and delta H will equal to delta H1. So delta H1, that means, should equal to minus 1000 plus 1500. And now let's say we did the math for this. Minus 1000 plus 1500. If you guys are good at maths, you should clearly see that we get plus 500. And as we clearly see, this matches what we have here, showing clearly that Hess's law is correct. that A plus B to C is the same as going for an alternative route. Now, you might be wondering, how can we use this in an exam? Clearly, we have an example question here. So let's quickly read through this together. The standard enthalpy change of combustion. Okay, so that's a very key information. The standard enthalpy change of combustion of glucose can also be determined indirectly. Now this is another key word. This is already indicating to you that it should be Hess's law. So whenever you see something saying determines indirectly, just remember of our Lord and Savior Hess. Now, the question they already tell you, calculate the standard enthalpy change of combustion again of glucose using the standard enthalpy changes of formation below. Now this is your standard enthalpy changes of formation. Now the first thing we have to do is look at this. Now something in your head should be clicking right now, that this is actually not possible. You cannot have an equation like this. So this is when a Hess cycle comes in. Now we know we need combustion, and clearly in a combustion reaction we know that we can have C6H12O We can also have oxygen. Now we remember that Hess's cycle is like a triangle, so we need to get to the products. Our products for a normal reaction like this would be this right here, what we have right now, because this is what we're trying to make. So let's put this on this side. C6H12O six plus 6O2. Yep. Now we need to draw the final part of the Hess cycle, which is our arrows pointing down. Remember that, because that's a very important piece, that the arrow is pointing down. Now you might be wondering, okay, so I have a standard enthalpy change of combustion right now. So what should fit in the bottom? So for combustion, you would always want to put your combustion products. So if you see right here, we have our 6CO2 and 6H2O. Now this belongs right here. 6CO2 and 6H2O. Now, if we see, not everything's balanced as of yet. This is balanced, this is balanced, these are balanced. But what we're missing here is a 9. Now the first things you want to do, cancel out your 9s, your O2s. Because if you look in our enthalpy values, we don't have any O2, so it's irrelevant to the question. It just helps you out to balance it all out. Now we know that C6H12O6 gives us minus 1250. So immediately we're able to hear that C6H12O6 is minus 1250. Now we also have CO2 and H2O. So you're wondering, how can I work that out? So you have your CO2 here, you have your H2O here. Each of them have a value of 6. So clearly right now you get your calculator and you go minus 394 times 6 which equals 2364 minus 2364. Do not forget your minuses. They're very important to this equation. Now you want to find out your water. So let's do this. Minus 286 times 6 equals, and we see that our value here will be minus 1716. Now if we get these totaled, we get a value of minus 4080. So here we put 4080. Now this is where the Hess cycle truly comes in. So firstly, we can go down this arrow, and as we're already going in the direction, our notation here stays the same. Now we're going up, but this arrow is pointing down. So what that means is that we need to change the arrow pointing up now, and this value goes from a minus to a positive. Because the arrow changes direction, it becomes the opposite of what it was originally. So now we'll have 4080 plus 1250. Hopefully you can see that. If not, I might highlight it to help you. Oops. I might highlight to help you if it helps. I think it makes it a little clearer. But let me repeat again. 4080 plus 1250. Now this value should actually give you minus 2830, which is the value here. 2830. And simply like that, that's how you get the answer. And now if we compare it to the mark scheme, you can clearly see they say that they want you to times the value, as we did here. They want you to times the other value to get one side of your arrows. Then they want you to work it out, and this is by following the direction of your triangle. So simply what you have to do is draw the triangle, write it as a proper equation that actually works, then do your maths. It seems easy, but it takes quite a bit of time, and bear in mind you only have 3 marks, so it's quite a tough question based on the time. This is not the only type of Hess cycle we have though. In the next question we're going to try together, we have something called the standard enthalpy change of formation. So now this is completely different to what we did before. Now the question is asking about hexane, and that we should calculate the standard formation of hexane using the standard enthalpy changes of combustion below. Here are our values again. Now for this question, we use a different type of Hess's triangle. It's still a triangle for sure, but we just draw it a little differently. So like before, first we need to draw our combustion products. So we write the value for hexane, which is C6H14, and we must write, well, if you want you can avoid doing the oxygen values, but for presentation purposes I will for now. Our O2. Now second part of this triangle, is our combustion products. So, if we do it now, we get 6CO2 plus 7H2O. 7H2O. And that's our top part. But now we're filling the triangle. The main part now we have to remember is that rather than having it pointing downwards, our arrows are supposed to point up. Because as it says in the name, it's formation. So now, instead of having elements that make a... rather than having combustion products, we now have elements at the bottom. And the whole point of formation is that these elements make everything up here. So if we look, we have a C bond, a H bond, and an O bond. So obviously carbon is just carbon. Hydrogen, however, is a H2 bond. And we know that oxygen is an O2 bond. But for now, we are going to cut out the oxygen. Forget about it. So now, we try to balance everything out, make sure everything's fine. And if you do balance it out correctly, you'll get 6C7H2O. Okay? Now, the main part is done. Now, all we have to do is the maths. So clearly, we know that 4,163 of this is from the C6H14. So clearly, let's put 4,163. Great, done. Now is the part where we do a little bit of maths. And let's do that in a nicer orangey color for now. Now, the first bit they ask is hydrogen. We have 7 hydrogen this time. So if we have 7 hydrogen, we have to do 7 times minus 286. Which, if we get the year 2002. Now, we have one set of values for this. We need our other set of values. So our other set is 6 carbons. 6 times minus 394. So we have that value now. And what does this total to? If you do it on your calculator, it'll be a minus 2, 3, 6, 4. Now once you total these up, you should get a value of minus 4, 3, 6, 6. Now if we go back to the main part of the question, they want the value of formation. So you might be wondering, how do I do this? So firstly, we need to follow the triangle arrows again. This time we're going downwards. So this becomes from a negative to a positive. And then we're going upwards, so our value here stays the same. So we'll get minus 4, 3, 6, 6. So then the math works out as 4, 1, 6, 3 minus 4366, which is minus 203. And that there is our answer. Sure, the question is hard. It's supposed to look hard. But once you get practice in it, it becomes really easy. It's like a little click in your mind. Because you know it's the same pattern every time, and it's either the arrows pointing up and the arrows pointing down. And then you just have to follow the arrow route. Now, I'd like to give you a little tip. Combustion, because this is all about energy, combustion will always have a negative value. So if you're doing combustion and you realize that one of your values are negative, that's when you should get worried and know that you must have done something wrong in the question. So that's a little tip that could help save you in your exams. Now let's look at the mark scheme. If we see, we've done this and we've done this to get this value right here. What else have we done? We've also found this value and we fixed it up and we got 203. So now I believe it's your turn for the video. Here's the question. I believe you should pause the video now and try give it a go, because the best way to improve and actually learn the topic is to take all the information in and practice it. And if you're able to successfully do it, then great. And if you're not, practice more, because practice does make purpose. So pause the video now and then I'll help you on after you've done. So let's try the question now. We see that they are asking for the standard enthalpy change or formation again, of butane this time. They gave us all the values and everything, but they did not give us the equation. The first thing, let's make sure we know the equation of butane. So the butane is C4H10. H10 plus 13/2 O2. Now let's have our little arrow pointing that way, and on this side we have 4 CO2 plus 5 H2O. There we go. Now we need to know that it is formation, meaning that this time we need to do it based on the combustion products that we have. No, sorry, formation, the elements we have, pardon me. And this time, because it's formation, the arrows point up. Now we know that we have a carbon, a hydrogen and an oxygen. So we put C plus hydrogen bonds, but no, it has to be H2 plus O2. Now remember what I said before? Oxygens don't matter, you can cancel them out. You have carbon and hydrogen. So we see we have C4, so that means it's 4C here, and we have 10 H's, which is 5 H's here. Now is the main part, the maths. So we know butane here is minus 2877. So minus 2877. Now we do everyone's favorite bit, some maths. Now let's say we start with carbon first, right? Now carbon here, we have 4. So we do minus 394 times 4. Simple as that. Which equals, if you do it on your calculator, minus 1576. Now let's move on to the next bit. Hydrogen, which is minus 286. So minus 286 times 5, which equals minus 1430. So now you know the next bit is that we total them up, which is minus 3006. So the tip I taught you before was that, remember, it's combustion. So we'll have to have a minus value. Okay? Don't forget that, that's very crucial. Minus value. So now, let's actually balance it all out. So we have minus 3006, correct? Now we have to follow the arrows. We're going down, so this arrow is already going the wrong way. We must point it down, and that changes this to a positive value. This is going the right way, so this is fine. So we should be able to do it now. Minus 2877 minus, sorry, it should be plus 2877 minus 3006, which equals minus 129, which is our answer. And if you got that, well done. You're really good at this, and hopefully you'll get better as you do more practice. If you didn't get it right, it's okay. You're still learning, and that's why you're on this video. And with more practice, you'll get better. And if we look at the mark scheme, we see the answer was correct, and we see the marks you get and how you work it out. Now, I'd like to thank you all for watching again, and if you do think the video has helped, drop a like. It always helps for me and pushes me on to make more videos. If you have any other questions about this topic, just ask in the comments, as it helps me because it helps teach me, and it helps you because you'll learn more. Subscribe for more videos because I'm still trying to make more of these to help me and all of you out there. Give any feedback on the video to help me improve, because everyone makes mistakes, and it's obvious that the only way to improve is by other people giving you feedback. And if you think the video was helpful, please share it out to others, because other people like you are suffering on these topics, and therefore if we help them out, it's always great. And with that, I'd like to thank you all for watching. Goodbye.